We want to find horizontal intercepts, otherwise known as x-intercepts, and that's just where my graph of my parabola crosses the x-axis. We have some names for these. Sometimes we call those zeros, roots, or solutions. And we have three specific cases that happen. So we'll look at a graph on the three cases. My graph may have two solutions, roots, zeros, or intercepts. It may only have one solution, zero, or intercept. And it quite possibly could have no, zero solutions, roots, or x-intercepts. Now, we find them a couple different ways. We're going to use one method here. We could have looked at a graph if maybe I had a graphing calculator. But we're going to take my function and set it equal to 0, because what's happening is my y, or my f of x, is equal to 0. So before we can do that, we need to know a little bit about a zero product. Product means multiply. If I have two items being multiplied such that their product equals 0, I know that either A equals 0, because 0 times B is 0, for sure, no matter what B is, or B is going to be 0 because A times 0 is automatically 0, because anything times 0 is 0, or both A and B equals 0. So we're going to be using this product rule when we know A times B, and we call A times B factors. So what we're going to do is we're going to find two items that are being multiplied together that equals 0. And we're going to use a zero product rule with this factored form, and all factor means is multiply. Notice I'm multiplying. So I know that if it's A or B, they're going to be able to be set to 0. So we're going to kind of highlight here. Here's my A, and I know that A could be equal to 0. In other words, x plus 2 could be equal to 0. If I solve for x, x is negative 2. If I just insert negative 2 back into my equation here, negative 2 plus 2 is 0. Negative 2 plus 3 is 1. Isn't it true that 0 times 1 is 0? Now the other item, not only A, but B could also be equal to 0. So here's my B. So I'm going to take my B, whatever it might be, and set it equal to 0. Subtracting 3. I now have my two intercepts. They happen at negative 2 and at negative 3. If I want to write them as ordered pairs, they would look like such. Now that I have them, what was the original quadratic? What was the quadratic in standard form? I have it in factored form, which is x plus 2 times x plus 3. And if I want it back into its standard form, I need to multiply. And when we multiply, we're going to do this thing called the distributive property. We're going to take the first x and we're going to distribute it. And we have kind of a mnemonic method that will help me. Multiply my first terms, x times x is x squared. Multiply my outside terms. Notice this x in front was distributed to both items in the second parenthesis, and I get x times 3 is 3x. I for inside, this 2 now gets to be distributed to the second parenthesis. 2 times x is 2x, and 2 times 3 is 6. So I'm doing this FOIL method, and you can kind of see it makes a little face here. Combining like terms, I get x squared plus 5x plus 6. And that's equal to my quadratic. What does my quadratic look like on a graph? Well, plotting my zeros, x-intercepts, solutions, whatever you would like to call them, here's negative 2. Here is negative 3. My a value is a 1. It's positive. So this is a narrow parabola hitting my x-axis twice. The 1 doesn't really affect the width, but I can see that it is opening up. So let's try the next one. What we want to do is take a and set it equal to 0, take b and set it equal to 0 from the 0 product property. X is equal to 0. It's already done for me. Solving, I get x equals negative 4. So those are my two intercepts on my graph. If I want to take and find my original quadratic in standard form and not factored form anyway, I distribute x times x is x squared, x times 4 is 4x. That is my quadratic. Notice I don't have a c term. And if I want to plot this, I know I'm hitting the x-axis at 0 and at negative 4. My a value is a 1, so I know it opens upward. Now, I don't know where my vertex is because this is not vertex form. If I'd put it in vertex form, I could have found my vertex. Repeating the process, take my a, setting it equal to 0, and my b. Either one of those has the opportunity to be 0, moving the 3. In other words, I'm just solving for x after setting it equal to 0. So minus 1.5 and a negative 1. So those are my two. They're not an ordered pair. They're two individual x-intercepts. So at negative 1 and negative 1.5, so they're very close to each other. Finding my original quadratic by taking 2x plus 3 and x plus 1 and doing that FOIL procedure, or if you want to think of it as a distributive property, distribute, I get 2x squared. Distribute to the next one, I just get 2x. Inside is 3x. Last is 3. Combining, 2x squared plus 5x plus 3 is my quadratic in standard form. I know from the 2 it's going to be narrow opening up. And there it is. Once again, I'm not sure exactly where my vertex is going to be located because of the fact that I don't have it in vertex form. A couple more. X plus 1 equals 0. Solving. 2x minus 3 equals 0. Solving. So now it's at negative 1 and positive 3 halves. So taking x plus 1, multiplying it by 2x minus 3 to get it back in standard form. I get 2x squared outside, inside, and last. Just the distributive property. Combining like terms. Looks like I have, this should have been a 2x. Combining these terms, I get a negative 1x minus 3. Here's my 2x. Here's my minus 3x. So this is a 2. Plotting on my axes, negative 1, 1.5. 2 is narrow opening up. So that's a general shape of my quadratic. Last one is a little bit more complex. Taking 5x minus 4, setting it equal to 0, moving the 4 and dividing by 5. Not a very pretty number, but 5/4 I can find. Taking 2x plus 7, setting it equal to 0, moving the 7 and dividing by 2 is negative 7.5, which is negative 3.5. So I can locate those on my axes here. Negative 3.5 and about 1. Now let's see what would happen when I take these and using my distributive property or my little method called FOIL. 5 times 2 is 10. X times x is x squared plus 35x minus 8x minus 28. Combining my like terms, I see that 10 is going to make this very, very narrow. 27x minus 28. Very narrow, but positive opening up. And not all of them are positive, but so maybe my vertex sinks very low. Again, I can't find that vertex right now because it's not in what we call vertex form.